two complex numbers. So you have 4 plus I minus negative 3 minus 2I. The key to realizing what you need to do with the imaginary unit is you don't treat it any differently than any other variable. So you have 4 minus negative 3. What's 4 minus negative 3? Is 7, correct? And then what's I minus negative 2I? What's I minus, how many i's is that? They're not multiplying. This is subtraction right there. I minus negative 2i is going to be 3i. And now you're done. That's all you do. That's all you do. There's no multiplication right there. There's no multiplication. 4 minus negative 3 is 4 plus 3, which is 7. I minus negative 2i is I plus 2i. What's I plus 2i? 3i. That's it. Radical expressions. Nice. So we have the square root of 4x plus 7 minus 4 equals the square root of 4x minus 1. Now that first one I've always told you is isolate if you can. There's no more isolation you can do on this one. At this point, what do you have to do? You're going to have to square both sides. You square both sides. So what does the right-hand side become? 4x minus 1. On the left, though, remember, you have to do 4x plus 7 minus 4 times what? 4x plus 7 minus 4. Like that, right? You have to do it out. You can't just square each individual thing. So what do you end up with? What's the square root of a table times the square root of a table? A table. So the square root of 4x plus 7 times the square root of 4x plus 7 is? So you have 4x plus 7. And then you have minus 4 of those things, and again minus 4. So minus 4 of them plus minus 4 of them is minus 8 of them. And then what's minus 4 times minus 4? So you have this. And before you square again, you're going to have to square again because you have that radical. You want to clean things up, right? So if we clean them up carefully, it's surprising how many times people mess this up. You get 4x minus 8 root 4x plus 7 plus 23. 16 plus 7 equals 4x minus 1. What's on both sides? How many 4x's do you see?
4x.
Yeah, so you can get rid of them, right? So what do you end? And then let's subtract 23. So what do you end up with? Negative 8 root 4x plus 7 is equal to negative what? What's negative 24? What should I divide both sides by? So you end up with the square root of 4x plus 7 equals what? 3. Now what can you do, or what should you do? Square again. So you square both sides, and you end up with 4x plus 7 equals 9. So 4x equals 2. So x equals a half. Now here's the thing. What have I told you over and over again you need to do with these radical equations? You really need to check them, right? You really, really need to check. So we're going to check this. It's x equals 1/2. So what do you do the left and the right. So it's going to be 4 times 2 minus 7, the square root of that, minus 4. That's the left side. So what's that going to be? The square root of 8 minus 7 is square root of 1 minus 4. Right? Is everybody with me so far? Oh, it's a half. What am I doing? It's not 2. You guys see, what am I supposed to plug in? A half, not... Does everybody see what I did wrong there? Yeah, thank you. So we end up with 4 times a half plus 7 minus 4. So that's going to be the square root of 9 minus 4. So that's 3 minus 4, which is what? Negative 1. Well, what's the other side of this? It's the square root of 4 times a half minus 1, which is the square root of 2 minus 1, which is the square root of 1, which is 1. Are those equal?
No.
No. So you'd have to say then no solution to this one. But you'd have to do all that work to show that there's no solution. Your potential answer, your only potential answer is a half, and it doesn't check. It does not check. Why isn't that in most simplified form? Yeah, we don't like the square root, right? So what do we need to multiply by, Rachel? Not enough, because if you multiply by root 2, you also have to multiply the 3, and you're going to have it closer. You need 3 plus root 2 over 3 plus root 2. You have to do the conjugate, the opposite of it. So when you do this, what does the top become? The root 8 distributes, right? So you end up with 3 root 8 plus what? Root what? 16. All over. Now you have to multiply this out. You end up with 9 minus 3 root 2 plus 3 root 2 minus what? Nope. Minus 2. Right. So does this simplify kind of nicely?
Yeah.
Yeah. It's going to be 3 root 8 plus what? 4. Over, what's 9 and negative 2? 7. Is there anything left on the denominator? No, because these cancel. So there's your final answer right there. You have, this is called rationalizing the denominator. Why is it called rationalizing the denominator? Do a literal translation. We have made the denominator rational. What was the denominator before? That is it, yes, that's a clinical definition, but what it went from being something to rational, so it started what?
Irrational.
This is an irrational number right here, because you see that this number right there? Remember that proof I did? We started with root 2 is equal to p over q, remember that? What does rational mean? First five letters, what is it? So what does rational mean? Can be written as a fraction of integers. So the idea is this denominator, 7, can you write 7 as a fraction of integers? Yeah, it's 7 over 1. Exactly.